Hello, fellow code monkeys. We are going to take a break from our usual C programming content, and we're going to go back to Linux stuff. For this one, we're going to be looking at a tool I use all the time called Docker. And Docker is a convenient, handy dandy thing that runs containers. And a container is a sort of self contained environment similar to a virtual machine, but less. It doesn't attempt to emulate hardware in any way. It mostly provides the trappings of an operating system, and then it sort of connects to your actual physical hardware more directly. So it can be a little less secure, but it's also easy to set up, easy to deploy, build, set up, tear down, all that good stuff. That said, let's hop right into it. First thing to do with Docker is you can use this cool command, docker ps-a. Will show you all your it's all containers if you have the -a. I believe if you don't have that, it's only running containers, and I don't think that one's running. And yeah, we take the -a off, you don't get the stopped containers. You can see, oh boy, there's a lot of stuff in here, but you can see all your container images if you do docker image ls-a. ls instead of ps, keep that one straight. I get it wrong every single time. So you can see I'm working on some stuff. The -a shows all these layers that don't have any kind of tag on them. Those are intermediate layers for the ones usually directly above them, I believe, is how that works. So this one here is going to be built on all these layers beneath it. All right, next, let's run a container. That's what we're all here for. Looks like we got Debian Bookworm Slim. We could just fire right up. And I don't actually run these straight off the command line a lot, so forgive me if this doesn't work the first time. -D for detached mode, and then I believe you want the name, and we will just call it Debian. And then I believe we are going to want the name of the image, which would be Debian : bookworm, bookerworm, haha, slim. Unable to find Debian Bookworm Slim. Did I spell it wrong? I sure did. Bookworm Slim. There we go. Now we should have a Debian container. That wasn't the right command. Docker ps-a. I think you can also do docker container ls-a. Should get you the same thing. Yeah. Nice today, so we're going to have to roll without it. So as you can see, we've got a Debian box that attempted to run bash and it exited almost immediately. That is one of the quirks of Docker, is that your container has to have a process running in the foreground or the container will just stop executing. So, how do we go about doing that? Well, first, let's get rid of rm for remove. What do I call it? Debian? I should just get rid of Debian. When we go back up to run, you can actually give it an entry point, and it does specify there's a -- entry point. And it's been a while since I've used this, so I don't remember exactly how it works. I think you do something like this. ~f dev null should do the trick. Failed to create daemon entry point. executable file not found in path. Really? What happens if we do that? Conflict, okay. Now is it okay? Let's hear return entry point, tail F dev null. Why did it not like that? I think we don't actually need to use entry point. You can just leave it as the last set of arguments. It will interpret that as something to execute. It's slightly different, and what the actual difference is something that I'm not fully aware of myself, but both of these will work for basic purposes. So we're going to start with that, and we're going to run with it. Ow, come on. There. Our little, that should work. No such file or directory, tail F dev null? You know, I'm gonna be honest with you folks. I didn't expect to run into this issue, like, immediately. Let's see here. I usually end up putting these in scripts, so let's see if we make a script. Let's call it something. Oh, practice deb.sh. Ah, that's a terrible name. Run.deb.sh. That's much better. Shebang /bin/bash. Docker run -d -name Debian. And the image is going to be Debian bookworm slim. Eventually you get to the point where you start remembering these a little better. And I think we'll just put a first argument in there. That should do the trick. This usually works. Don't forget to chmod. Things aren't executable by default. /run, and then we can use quotes because it'll unquote it before it tries to execute the actual command, and then it usually works, right? Okay, it likes it that way, it doesn't like it the other way. I'm going to keep it real with you. I don't know what the difference is. Sure is strange to me, but, you know, you do what you gotta. Alright, so now if we docker ps, that's our only running container. If we do ps-a, we can see that stopped one. Hurrah. So, why did that one... Okay, we're not going to get sucked into that right now. Anyway, the point is, you can see it's up, it's running tail-f/dev/null in the foreground of its shell. This tail-f dev null is a very handy Docker trick. You can use it to force something to run in the foreground if the thing you're trying to run will only run in the background. Sometimes they call that running in demonized mode. Anywho, now that we've got it up and running and all stable and things like that, we can do other fun things to it, like, say, get inside it. Docker exec stands for Docker execute. -ti. One of those binds the output to the shell we're currently in. The other one binds the input to the shell we're currently in. There might be a reason to only use one at some point. I almost always use them both. And the container name, Debian, and what we want to execute. We want to execute bash. Ta-da! We are inside, and you'll notice we are at the root of the file system. Look at that. And we can do basically anything in here we could do on any Debian system. Keep in mind, though, that these slim images that we're using are very trimmed down. They don't have man. I don't think they have GCC installed. I don't think they even have Nano installed. None of that stuff. So usually that's actually the way you want it because you're going to be running some kind of server in here, is what I tend to use them for. Um, and if your server's already compiled, you don't need GCC. You're probably not going to need to be doing a lot of text editing in here. You're not going to be looking up man pages in here. You're going to be looking that up on a browser somewhere else or in some other operating system that you got running. So let's install some stuff. That's a good idea. So first thing you do, Alpine doesn't need you to do this, but all the Debian systems do. You got to run your apt update, and that's going to go out, and that's going to synchronize our internal list of the package repo. Maybe list wasn't the right word. It's going to synchronize our internal package repo with the external one out on the internet. Very handy. I think it is just apt update. And it found that we have some packages we can upgrade, so we can go ahead and upgrade them. You're going to get very used to using -y or the yes program, because when you're setting... Ooh, did stuff fail? No, looks fine. When you're setting up a container, you're not going to have any kind of user interactivity at all, and you're going to need to figure out how to get around that. A lot of times, there's built-in stuff where you can say use -y like we just did to automatically force a yes. Other times, you're going to have to get creative. I think it's installed. Yeah. Yes just outputs a bunch of y's until you force the end of the execution. So if you do, it doesn't make sense anymore, but I'll just show you how it works. You can do yes, and then you can pipe the output to apt upgrade, and that'll just work. It's not going to do anything because there's nothing to upgrade, but if upgrade didn't have a -y, that would be one way you could do it. I think yes can do some other things too, but that's mainly what it's used for, is to just say yes to things. Anywho, I promised you we'd install some stuff, so I think we can do apt install. How about, I think libcdev is what it's called. I think that's the right one. I think libcutils is already installed. I think that's the runtime stuff. This is the compile time stuff. Unable to libcutils. Okay. I think it's called something else. Usually there's a package that's called something like build... Oh, spelling, folks. Build essentials. How are we doing on time here? We're at 13 minutes. Okay. We could cut this short. This is important stuff, but this isn't the thrust of what I want to get at. Build essentials, I believe, includes like libcdev and GCC. Oh, I'm sorry. It's just build essential. And it's going to be 314 megabytes. Blah, 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 blah. Look at it go. And as long as we're here, apt install nano. Oh my. Do we already have it? Oh, okay, we already got it. I don't know what it was complaining about then. Anywho, we've got stuff installed now. You can see we have GCC. It can be a little hard to read. Sometimes you just got to put extra lines between things to make it easier to read. Usually I go into root, and you can go into bash rc, and there's a pretty arcane line in there, but you can do stuff like force it to output empty lines between everything. It makes it much more readable. But that's something you're probably not going to mess with inside a container. Anywho, now that we've seen the basics of messing around in one of these, let's go see some other stuff. Back up to root, and we're going to put a file down. Echo. Hiya, folks. And we got our hello there. We can go ahead and use our simple exit to get back out of the container. And let me see if I remember how to do this correctly. I've not done this in quite some time. Docker cp. We're going to go from the container, Debian. Oh my lord, is it colon? Ah, okay. I remember how this works. I don't think we actually need the slash in there. That should have worked. And there we go. Cat hello.txt. And there it is. So that would be like your first way to get things in and out of a container. There's other ways to do things. You can make what's called bind mounts, where you're essentially sharing a folder between your host system and your container. That's got some security issues associated with it. You can create root, root-owned files inside a container, and then if you put them into a bind-mounted folder, due to some trickery I don't think I want to get into at this point, they'll be root owned and root-owned files outside of the container as well. It has to do with how the operating system recognizes ownership of a file. But it's not really that hard to work around. If you use this docker cp command, then you tend to kind of avoid that issue. You can put things back into the container too. Let's create another file. Echo goodbye everybody spelling. Call this drnick.txt. And we're just going to cheat a little bit. That's the one we wanted. We'll go. Should we use /? We should. txt to Debian. I don't. Can we just do that? Nah, I didn't like that. Okay, fair enough. And if we go ahead and open that back up, ti debian bash back inside the container, do an ls, we can see we got Dr. Nick. And there it is. Handy stuff. What else can I show you all in about 2 minutes? I guess I can show you how to open a port. We're not going to do much with it, but it is worth seeing. We'll come back to it in the next video, whenever I get around to that. rm-f. -f will remove a container even if it's running. And we called this one Debian. Alright, now we are going to go into our script file there. What's it called? run.deb.sh. Naming files is important. So, if you want to open a port such that the container can access the network, you're going to use -p. And when you got a situation where you got your single character switches, you can push them together like that, you can spread them apart like that. Doesn't matter, it's all good. There's usually a long version of all of these, so you do port. I don't actually know if that's right or not. We're not going to get into it now. Okay, so if I remember correctly, the way you do this is it's the external port. Let's go with 3000. The internal port, and then the protocol. And the protocol this time, if you don't specify a protocol, I believe it'll open UDP and TCP. if you specify TCP, it didn't used to do this, there was an update at some point, it'll open both the V6 and the V4 port. I don't think that's necessarily super desirable, but I also do not know how to stop it from doing that. I'm sure there's a way. Maybe one of you fine, intelligent young people can tell me how in the comments. Then let's go ahead and open up TCP. You know what? Let's pull a sneaky. Can we do that? Will that work? That might be a bit fancy for how much time we have left. Oh, that's not how that should work. Okay, so we can run it, and it needs to run tail f dev null ta-da docker ps-a, and we can see right here that we've got an open port. This one with the dots is going to be your TCP version 4. This one with the colons is going to be your version 6. If you don't know what that is, don't worry about it for now. If you do know what that is, you're a step ahead of the game. I think that's where we're going to call it here. Next time we'll get to running something a little more interesting. Maybe we'll have, what is this called? SSH? Set up an SSH or like a netcat or something so we can actually see what's going on when you connect to a Docker network. It actually creates a pseudo network with its own IP address and things. I don't actually know how to check that. There's like there's a logs that you can open up, but there's also just like a status that you can look at. And you pipe that to grep and you look for the IP address you can get out of that. It's usually like 172.16.0. something, I think is the pattern it uses by default. Anywho, lots of things to think about for the future, but this is just an intro video and we're a bit over time. So I'm going to say thank you all for watching. I hope you have a great day and I hope you learned something. Bye!